modeling real-world problems with linear functions. In the real world, problems are not always explicitly stated in terms of a function or represented with a graph. Fortunately, we can analyze the problem by first representing it as a linear function and then interpreting the components of the function. As long as we know or can figure out the initial value and the rate of change of a linear function, we can solve many different kinds of real-world problems. Given a linear function f, an initial value and rate of change, evaluate f of c. Step 1. We determine the initial value and the rate of change, which is the slope. We're going to substitute those values into f of x, which is equal to mx plus b. And then we're going to evaluate the function at x equals c. So for example 8, it's saying use a linear function to determine the number of songs in a music collection. Marcus currently has 200 songs in his music collection. Every month he adds 15 new songs. Write a formula for the number of songs n in his collection as a function of time t, the number of months. How many songs will he own in a year? So, in number 1, the initial value for this function is 200 because he currently owns 200 songs. So the initial value means that at n of 0, meaning when the input is 0 or time 0, the output is 200 because that means that he currently has 200 songs. So then that would say that b is equal to 200 because that represents a y-intercept. When x is 0, what is the y value? Well, the y value is 200. So therefore, b being 200 represents the y-intercept. Now, the number of songs increases by 15 songs per month. So the rate of change, or the slope, is 15 songs per month. Therefore, we know that m is equal to 15. And then we can substitute the initial value and the rate of change into the slope-intercept form of the line. So we know that b is equal to 200, and we know that m is equal to 15. So now we're going to plug that into our function formula. So f of x equals m times x plus b, where m is 15 and b is 200. But recall that the formula is saying the number of songs n, so we have to write n here. Okay, and it's a function of time, so that means t is the input. So therefore, we end up getting 15t plus 200. So now we can write the formula n of t is equal to 15t plus 200. Now with this formula, we can then predict how many songs Marcus will have in 1 year. Well, how many months are in 1 year? We know that there are 12 months. So in other words, we can then evaluate the function at t is equal to 12. So now this becomes n of 12, which is equal to 15 times 12 plus 200. Well, 15 times 12 gives us 180. 180 plus 200 gives us 380. So therefore, Marcus will have 380 songs in 12 months. Now notice that capital N is an increasing linear function because the slope is positive. So as the input, the number of months increases, the output, the number of songs increases as well.